Welcome back, children. I'm Srinivasan here. We're going to discuss exercise 1.1. I hope you would have seen the concepts of relations video so that you can able to follow this sums. First question, first part says determine whether given relation is reflexive, symmetric, or transitive. So, knowing the basic definition of reflexive, symmetric, and transitive, we are starting this problem. The formula in the relationship what is given is 3x minus y equals 0, which means we can solve it for y. 3x minus y equals 0, which means y equal to 3x. So this is a simple relation given here between x and y. Now x can take values because this is a function, this is a relation defined from a to a. So 1, 2, 3, 4 to 14 are there. When x equals 1, what will be your y? 3 times 1, right? So you have a 3. So you have one order pair as 1 comma 3. Then x equals 2, you have y equals 6. X equals 3, y equals 9. Then x equals 4, you have y equals 12. Then x equals 5, you have y equal to 15. But this cannot be taken. Why? Because you have up to only 14. So this is not possible. So these are the order pairs near relation 1 comma 6, 2 comma 6, 1 comma 3, 2 comma 6, 3 comma 9, and 4 comma 12. Now we are not going to have this one, so we'll erase it off. Now we'll define the relation R is equal to these order pairs 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. Now this is your order pairs in the relation. On seeing this, you have to decide whether this relation is reflexive, symmetric, or transitive. What is the first? We'll check reflexive. What is the rule for reflexive? For reflexive, we know when for every x belongs to a, any element belongs to a, then x comma x should be there in your relation. Then you can say it is reflexive. Otherwise, it is not reflexive. So you take an element 1 belongs to a. 1 is there in the set a. Okay. Now you should check 1 comma 1 belongs to R or not. 1 comma 1 is not there. So 1 does not have its reflection. So 1 comma 1 does not belongs to R. Therefore, this relation R is not reflexive. So we conclude that it's not reflexive. Now we'll go for the symmetric. For symmetric, what is the rule? For symmetric, for any x comma y belongs to a, any two element belongs to a, then this order pair should be there. X comma y should be there in R. Then this implies y comma x should also be there in R. If it is there, we'll call it a symmetry. So choose any two elements. I'll choose 1 and 2. So 1 and 2 belongs to A. Okay. I'm checking whether I have 1 comma 2 is there. I don't have 1 comma 2. So I will choose any one from this relation. I take 1 and 3 because 1 comma 3 is there. So I'll choose 1 comma 3. 1 comma 3 belongs to A. And I see the order pair 1 comma 3 belongs to R. But I don't have 3 comma 1 in the relation. Can you see that 1 comma 3 is there, but I don't have 3 comma 1. So 3 comma 1 does not belongs to R. Therefore, R is not symmetric. So we concluded it's not reflexive. It is not symmetric. Okay, children. Now the third rule, transitive. For transitive, what is your rule? For any three elements, x, y, z belongs to A, then order pairs x comma y belongs to R, and y comma z belongs to R, then you should have x comma z belongs to R. X comma y comma z should be there in R. Then x comma z belongs to R, then you can call it as transitive, otherwise you cannot. That is your order for first element and the second order for second element. Okay, x comma z should be there. Now I check 1 comma 3 is there, 3 comma 9 is there, but 1 comma 9 is not present. I'll take this order as 1 comma 3, 3 comma 9, but 1 comma 9 is not there. So I'm going to mention that. Let me take 1, 3 and 9 belongs to A. Of course 1, 3, 9 is there in the set. Also 1 comma 3 belongs to R and 3 comma 9 belongs to R, but I don't have 1 comma 9. But 1 comma 9 does not belongs to R. Therefore R is not transitive. Okay children, so it is not reflexive, not symmetric, as well as not transitive. This completes first question, first part. Now children, the second part of the first question. Now the relation is defined from n to n, natural numbers, set of natural numbers. We know natural number starts from 1. See the formula, it is given as the relation given as x, y equal to x plus 4, x less than 4, your input is less than 4, so x is equal to 1, 2 and you have 3. Only these 3 are the domain elements. That means you can give it as an input. Now y equal to x plus 4, which is equal to 1 plus 4 is 5, y is equal to 2 plus 4, which is 6, and y is equal to 3 plus 4, it is 7. So your relation contains order sets 1 comma 5, 2 comma 6 and 3 comma 7. These 3 order pairs are only present in the relation R. Now you need to check it is reflexive, symmetric or transitive. Now let us check. You are right for reflexive, again the same part you can write. For reflexive, you know, for every x belongs to A, the set A, here x belongs to n, your x comma x belongs to R. So I take an element 1 belongs to n is a natural number. I have to check whether 1 comma 1 is present in the relation or not. You check whether 1 comma 1 is there. No, it is not there. Therefore this is not reflexive. Okay children, the second question, the second condition for symmetric. For symmetric, I check, you take two elements x comma y belongs to n, then the order per x comma y should be present in R. Then if you have, this implies when you have y comma x belongs to y comma x, if it is present in R, then you can call it as symmetric, otherwise it is not. So let me take 1 comma 5, I check 1 comma 5 belongs to n, of course they are all natural numbers. Now I say 1 comma 5 belongs to R, yes it is present in R. Now can you see 5 comma 1 is there, 1 comma 5 is there, 5 comma 1 is not there, so it does not belongs to R. Therefore R is not, this relation is not symmetric. It's not symmetric. You can mention R is not, the relation R is not reflexive. Okay children, then for transitive, what is the condition for transitive? Take 3 elements belongs to the n, x comma y should be there in R, y comma z should be there in R. Okay, then this implies x comma z is there in your R, then you can call it as transitive, otherwise it is not. So let me see, 1 comma 5 is there, I see 1 comma 5 is there, but 5 comma 1 is not there. I am unable to check the condition. So when we are unable to check the condition, what is the important point of a transitive when you are learning concepts? When you are unable to check the condition, then you should take it as transitive. So I don't have the next pair to check. 1 comma 5 is there, but 5 comma any element is not there. So I am unable to check the condition. Therefore, you take R is transitive. This takes an advantage, so you'll write it as transitive. Again, you understand, children? When you are unable to check the condition for transitive, you should take it as transitive. Okay, that's all. 2 comma 6 also, you see you don't have 6 comma 2, then only you can talk about 2 comma 2. So the condition is not met. If you have still you have a doubt, you please go to that relations, concepts of relations video. In that I have said about important points about transitive. There you can see. Thank you, children. This completes second part of the first question. Welcome back, children. Now the third part of the first question, third part. Here A is the set A is given with the elements 1 to 6, and the relation is defined as y is divisible by x. Okay. Now let us write the order pairs of this relation. We know every element is divisible by 1, so we'll write it as 1 comma 2, then 1 comma 3, 1 comma 4, 1 comma 5, and 1 comma 6. Okay, children. Okay, then the elements itself, 1 is divisible by 1, 2 is divisible by 2, so we can write that 1 comma 1, 1 comma 2, sorry, 2 comma 2, likewise 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. Every number is divisible by itself, so we have finished that one. Now we'll check. 3 is divisible by 2, no. 4 is divisible by 2, yes. So you include 2 comma 4. So 4 is divisible by 2. 5 is not divisible. 6 is divisible by, yes. So then what else is there? Then 4 is divisible by 3, no. 5. 6 is divisible by 3, yes. So 3 comma 6. That's all, children. No other possibilities are there. The second element should be divisible by the first element. Y is divisible by x. Okay, children, do you understand? Now for reflexive, choose any one element from the set A. Then you should check whether x comma x belongs to R. I take an element 1. I see 1 comma 1 is there or not. Yes, it is there. If I take 2, 2 comma 2 is there. So every element has its reflection. 2 comma 2, 3 comma 4 comma. So it is reflexive. So you can write every element. So we have, how can we write? We will write it as 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6 belongs to R. Therefore R is reflexive. For every 1 to 6 belongs to A. Belongs to A, you can write. Or from the given relation from the order pairs, we see that it is reflexive. That will do. We'll finish now. Now for symmetry, so take any two elements, x comma y is present in the set A. Now you have to check whether xy, the order pair x comma y belongs to R, then y comma x belongs to R. Now take the first order pair 1 comma 2 is that. You have to check 2 comma 1 is present in this or not, in this relation or not. 1 comma 2 is there, but you don't have 2 comma 1. So any one pair is enough. So I see I'll choose 1 comma 2 belongs to A. Then I observe that 1 comma 2 belongs to R, but 2 comma 1 does not belongs to R. Therefore not symmetric. R is not symmetric. So we conclude that. Then for transitive, choose any 3 elements so that you should have such pairs. I'll choose 1 comma 2, 2 comma 2. I have 1 comma 2. Yes, it is there. You can pair like that. So for every order pair you have to check. Now I taken 1 comma 2. I can see 2 comma 2. 1 comma 2 is present. Yes. Then I see any order pair starting with 2. Yes, here it is. So 1 comma 2, 2 comma 4. I should have 1 comma 4. Yes, it is there. Then I see starting with 2. So 1 comma 2, 2 comma 6. 1 comma 6 should be there. Yes, it is there. So this is the checking method. So 1 comma 3 is there. Then I have to check what are the order pairs starting with 3. I can see 2 order pairs are starting. 1 comma 3. Then I see 3 comma 3. 1 comma 3 should be there. Yes, it is there. Next is this one, 1 comma 3 3 comma 6, then 1 comma 6 should be there as it is there. So for each and every pair you have to check. So 1 comma 4, then I see 4 comma 4, this is the only order pair starting with 4. So 1 comma 4 4 comma 4, 1 comma 4 should be there, it is there. Similarly 1 comma 5 5 comma 5, 1 comma 5 is there. 1 comma 6 6 starting with, so 1 comma 6 is there. 1 comma 1 2 comma 2 3 comma 3 4 comma 5 are always transitive, no doubt. 2 comma 4, do you see any order pair starting with 4? Yes. So 2 comma 4 4 comma 4 2 comma 4 is there. 2 comma 6 6 starting, 2 comma 6 is there. Okay, children. Then 3 comma 6 6 comma 6 3 comma 6 should be there, it's there. So you can see every element is transitive, it's having transitive. Therefore from the order pairs present in R, we see that R is transitive. And you need not want to write every element because you are given as a common. So that's why this common statement is required. If you say x comma y comma belongs to A, you can commonly say x comma y belongs to R, y comma z. So I observe that x comma. If you don't write this common statement, if you take only a few elements and you write, they will not accept. This sort of mistakes commonly occur in the papers. So that you should understand, children. So you write safe side, always write the statement with the x or ab, whichever you choose. You write that and you can take in one particular pair and you can say it's not. So this question, R is reflexive, R is a transitive, but it is not symmetric. This completes question number third part of the first question. This question, children, first question, this is fourth part of the same question. Yes, fourth part. The question says R is defined from, the relation is defined from integers to integers. You need to say the order pair x comma y, the relationship is x minus y is an integer. First, for doing this question, children, you should have an idea about integers. Integers of these numbers, whole numbers, both positive and negative, up to negative infinity to infinity. So this number line indicates an integer line. Okay, these are the integer numbers. So if you take any two numbers, now you take any two number, any one number particularly, you take any one number, you have to check the difference between the two numbers should be an integer. Say for example, I'm going to take 1, then I should say if R contains 1 comma 1, if 1 comma 1 belongs to R, which means 1 minus 1 should be an integer. 1 minus 1 is 0, it's an integer. You take 2, 2 minus 2 is 0, it's an integer. Take minus 1 minus of minus 1, because the formula is x minus y, right? So I'm checking for reflexive. So minus 1 minus of minus 1 is minus 1 plus 1, which is equal to 0. So the difference between any two integers or zeros, the same number itself, it's a 0. So we'll go for that. For every element A belongs to z, set of integer, we can observe that the difference between the two numbers, I mean the same number, the difference between the same number is also an integer. So a comma e belongs to R. Okay. So this can be explained in a common way, not choosing any particular number. So for every a belongs to z, a comma a is also an integer, it belongs to R. Therefore R is reflexive. The first part gets over here. I chose one number and I showed the difference of that number is same. You can choose any one number, you subtract with the same number and check whether it is integer. Number 2. Now you have to choose two numbers. A comma b, belongs to z. Then the difference between the two number being an integer. Okay, you have to check if b comma a is also an integer. Choose any two numbers from here. You can choose minus 2 minus 1. Okay, minus 2 minus 1 belongs to z because they are integers. Okay, now we'll check the difference. Minus 2 minus of minus 1, minus 2 plus 1, which is minus 1. Now interchange minus 1 minus of minus 2, So minus 1 plus 2, which is 1. Again, this is an integer. Need not be same. The number and the value need not be same. But you have to check whether they are integers. Yes, they are integers. So now we cannot choose any particular value, right? We have to write it in a common way. So we see that a, b, any two numbers belongs to an integer. Then the difference of them being in relation, we also see that this implies a comma b implies, you can use the word implies, b comma a also belongs to R. Therefore, R is symmetric. Okay, this first one got over, second one. Now third one. Similarly, we choose three elements A, B, C belongs to the set of integers, and you should tell them A comma B belongs to R. The difference of two integers being in an integer. Then B comma C is also an integer, so it is in a relation. Then A comma Z also belongs to R, therefore transitive. Okay, we will explain that here. First, we'll finish off this. So A comma Z belongs to R, therefore R is transitive. Now, we'll try to understand. Choose any three numbers, minus 2, minus 1, 1. So minus 2, minus 1, 0 belongs to set Z. They are all integers. Now relations you have to check. Minus 2 minus of minus 1, which is minus 1, belongs to R. Which belongs to R? Minus 2 minus 1 belongs to R. Now minus 1 and 0. Minus 1 minus of 0, which is minus 1. Don't see the and the numbers answers are correct. It's not like that. Don't take it in a wrong way. Belongs to R. Okay. Now you have to check minus 2 and 0. Minus 2 minus 0 will be minus 2. Yes, they are also an integer. It's an integer. So minus 2 comma 0 belongs to R. Therefore, this is transitive. Okay, children. For doing this question, you should have an idea in your mind that what are integers, and difference between the integers is always integer. If you have that idea in your mind, we can do this question easily. This completes the solution of part 4 of the first question. Thank you, children.